Ready to start? I think we're getting ready. Okay. There we go. Yeah. Hi, my name is Oskar, and I'm going to talk to you about fast and fearless evolution of server-side web apps. I work with Haskell at a company called Empowered in South Africa, but I work from Sweden. So I do not commute back and forth. Today, after a high-level introduction and some motivation, we'll talk about web apps, and more specifically about writing web apps in Haskell and what kind of nice features we get out of that. I'll demonstrate this using 3 web frameworks available in Haskell called Scotty, Yesod, and Airship. And I'll also say a few words about client-side technologies in the end. Well, starting with the introduction and motivation. There are many reasons to evolve software. We get new feature requirements, we need to do bug fixes, we do refactoring to make our program nicer to work with. There are external factors pressing us to change our programs, like new regulation or software or services getting deprecated, kind of forcing us to change our programs. I mean, the ideal might be to not do anything with the programs if they are kind of done, but usually that's not the case. And also, we might change them to for purpose of recruiting. We might use a newer technology or something to attract developers coming to our companies. And when doing this, when evolving software, we risk having delays and not delivering on time. We risk introducing errors and producing badly performing or just plain incorrect software. And also, on another kind of dimension, to burn out and to press the team too hard. And all these risks, I'm sure you've felt all these things going on, and usually they make it scary to do the change you want to do. You have some, you know, kind of how you want the software is doing one thing, and you want it to go over there, but it's so scary, so you might kind of work around it or avoid the change you really want to do. And I think that fear of evolving software as you want to do has a huge impact on our systems and how they get designed. And with better tooling, I think we can reduce that fear. We will probably never remove it entirely, but we can make it less significant. And by using tools that give us stronger correctness guarantees and making it possible to make more robust software in terms of error handling and so on, and the runtime properties of the software. But also things like getting faster feedback and knowing that this is working when you're writing it, and being able to not have to wait a day for some big test suite or CI thing. And there is another aspect to this about communication, about communicating your thinking to other programmers and to yourself in the future. And I think there are some tools that are better at these things than others. And one is functional programming. Maybe I don't have to convince you much about that, as you're here on the functional conference. But there's also type systems, and not necessarily static type systems. You might get a lot of leverage out of a dynamic type system that is robust in other ways. But I do like static typing, so that's what I'll be focusing on anyway. And then there's error handling. And same here, it doesn't have to be statically typed error handling. Like Erlang is famous for its error handling without being statically typed. But there's a lot of different benefits going on in the functional and these related topics. So let's talk about web apps. I think many of us work with the web in one or another way, maybe not directly writing HTML and talking to the browser, but our systems tend to interact with the internet and the web in the end somehow. Maybe all of you don't do this, but I guess many do in the end. And currently, single-page apps are very trendy on the front end. And these work more like desktop apps, really. You've moved a lot of the application's state and the execution from the server to the client. So it's very different. And they tend to reinvent parts of the web browser for better or worse, you might say. But it's a different model, and there are some downsides to this. One is that if you don't have the JavaScript, or if it fails to download for some reason, or something is messing up with the JavaScript, then you have no application. And I guess someone here is thinking, hey, wait a minute, what about universal web apps or isomorphic web apps? This is a solved problem. We don't have to worry about that. We can just run it on the server instead. But usually when people talk about universal web apps, they're talking about initial rendering and not about transparently running the same application on the client and the server, because those are two very, very different things. It's really a kind of distributed system, and you're just moving that application logic to another part. I haven't seen that demonstrated to work transparently, but yeah, prove me wrong. And here's a little friendly reminder that newer doesn't imply better. And I think this is noteworthy, especially in the kind of JavaScript ecosystem or culture where there's new framework each day. And what I'm trying to get across is that it's not necessarily better to use single-page web apps because they're newer. But they might be a good choice for your project or for a part of your project, but they're not necessarily better than server-side. So please don't dismiss server-side web apps as like the boring old-school thing. It might be old school, but it's not necessarily boring or bad. I'd rather have server-side web apps as the kind of default baseline, and then when you need something else, you can go for that. So there's a thing called progressive enhancement, where you define like a baseline saying, we want to support every web browser from Internet Explorer 9 and upwards, and we won't require any JavaScript at all. And then from that, you can start feature detecting and adding more features into the application. So everyone that has Internet Explorer 9 and upwards gets something, and then it gets progressively better as you have a more modern, capable browser. Also very important to recognize here is that all code isn't equally valuable in your system, I'd argue. This is a kind of power law-ish thing, but you have some domain code, there's a core function of this software that you're building, and then you have loads of other supporting code and supporting features that aren't really the thing you're making money out of, but they still have to be there, kind of. So it might be things like settings, forms and pages, and logins and documentations and forums and all that stuff. And I mean, using React or whatever to build your about page, it doesn't make much sense, really. So I think you should use client-side code where it gets you some kind of return of investment, because it's adding more complexity. And if you want things like more snappy navigation for web apps, on the server side, there's things like PJAX and so on. If we then start talking about static typing and server-side web, you have all these nice benefits, where with compile time checking, you get more robust runtime with defined behavior, for instance, like in Haskell. You can use types where it makes sense to enforce certain properties and do like correct by construction. I'm not saying you have to do this for everything. It's same thing here. Use it where it makes sense and where you gain something from it. And yeah, with the static type checking, you have like a machine verified documentation in a way, with the types saying a bit about what the programmer is thinking. We can safely evolve our code base, or more safely at least, by reducing this fear of change throughout the whole code base. So I had this example from last week where one person in the business told me that we had misinterpreted a requirement. And I went into the kind of core domain module in our code base and basically put onto the keyboard what he said. Like I wrote what he said and got a compiler, fixed that, and it worked. And I mean, it's not always like that, but it happens surprisingly often. And Haskell is amazing at that kind of workflow. Another important aspect about doing this with server-side rendering is that you have the whole web application defined in Haskell, in this case. So it's not split by an API for some arbitrary reason. It's you have the whole thing compiling as one thing, depending on what tools you're using. But I'll show you the tools later. And with this, you can also focus your test on your domain and your really not writing tests to catch type errors. And you can use this technique of making your domain code free of side effects to make it more testable. Adding functional statically typed web to the mix. There are many languages and many frameworks supporting some range of this style, but I'd say you should look and base your decisions on the underlying patterns and the safety guarantees and try to see through the kind of shiny features. And what this often comes down to, I think, is that less power is more power in a way. As Michael said in the first presentation this morning, as you can't sneak in side effects in Haskell, you can have nice, powerful libraries like STM. If you could cheat, everything kind of falls down. So in that sense, less power is more power. And yeah, I've already said the word Haskell a bunch of times. So these examples in the following will be in Haskell. Basically, all the Haskell web frameworks build on this web application interface, or WAI. And this is a common interface between web applications and web servers. And it enables you to mix frameworks in one application. And it enables the one writing the server not to worry about the frameworks, and vice versa. This is very comparable with Java Servlet API or Connect for Node, or yeah, most languages have something like this. The benefit is that it doesn't use loads of XML like the Servlet API. And yeah, there's also a thing we'll be using called Warp, which is a fast and popular web server for Haskell, building on top of WAI, and it's using the lightweight threading system in Haskell, as Michael talked about this morning as well. So in the Haskell ecosystem, there are a lot of frameworks. Here are some of them, not all. And I don't have time to show all of these to you, so I'll be focusing on Scotty, Yesod, and Airship, which are a bit different from each other, so I thought that would be a good selection. Starting out with Scotty, I'm just going to grab some water. Scotty is inspired by this Ruby web framework, or yeah, called Sinatra, which is very simplistic. Scotty features routing, parameters, and form parsing. It's very easy to get started and setting up a web server and have something running. And it is extensible. I'm not going to say the word, but it has something to do with an M. So you can extend it, I'll leave it at that. And also, Scotty is very small. So if you build something bigger, if you decide to use Scotty for a larger project, you might end up kind of building your own framework. At least you have to figure out which libraries you need to bring in and how to combine them and set them up so that you get the features you need. So it's minimalistic in this sense, and you might, if you're a beginner in Haskell, it's easy to get started, but then you have to figure out things to extend it. This is a small Scotty app which has 2 routes, and it accepts GET requests to the root path. Can you see it's not small? It's okay? Yeah, so it accepts gets requests to the root path and prints welcome as HTML. And it accepts get requests to /greet/something, extracts that something from the path, that's the who mapping there, and then it prints hello who, or yeah, whatever string that is. This is how we run this app, and we're done. So this is like the hello world of Scotty, basically, and usually you want to write more HTML than just hello. So you might want to have like an HTML tag and a head tag and links to CSS and all that stuff. And so, of course, we try the naive approach first, and we go here. And yeah, this is not the end goal. Okay, this is very hard to read. It's horrible to write. We could like break out some parts of it into functions and concatenate those strings and so on, but there's a bigger issue here, and that's that we are doing what's known as stringly typed programming, which means we're just, concatenating strings and having no structure in what's in those strings. So we have no idea about the tags and so on in these strings. So can anyone tell me what's wrong here?
It's not
No escaping?
Who is not checked? It's not type safe.
Yes,
It's not the
correct. href is missing an escaped double quote before the string ends. And this isn't very easy. I mean, you were pretty fast, really. You should be compilers, but it's hard to see because there is a double quote already, but there must be one more inside the string. So we can make these errors, and this doesn't scale very well. Good point. So for those who don't know, Michael is working with Yesod, the web framework, which does protect you from these things. And if you're doing stringly type programming, you might risk having these things like injections and so on. Yeah, so this is not a good approach, okay? Let's not use it. Instead, usually we use some kind of DSL for defining our templates for HTML. So there are different kinds of DSLs. There are embedded DSLs, and there are external DSLs for HTML. Embedded ones means that you write the markup in regular Haskell source files using data structures and functions and so on. Two popular libraries for this is these are Blaze and Lucid. And then you have external HTML templating languages like Heist or Hamlet. The external ones are often written in an external file in some other format than Haskell. You don't write it as Haskell source code. But you can also use a technique known as quasi-quoting to embed them in Haskell, but it's still a separate syntax and so on. These languages give us type-safe templates that are composable, and they help us. This is a really nice thing. They help us produce valid HTML as well. So it's not only producing tags and attributes and so on, but real valid HTML according to that spec. So if we take the example from before and write it in Lucid, it looks like this. Is there anyone who don't think this is better than before? If you can sort of understand what's going on here. So what we're doing here, we're using functions and data structures to represent the HTML. And we're using function application to nest HTML in other tags, other elements. And we're using do notation to do juxtaposition, that is, put them as siblings next to each other. We're using lists of pairs to express attributes. Like you see the meta tag and the link tag take a list of char sets, UTF-8, and so on. And you can notice here that some of these functions do not take any content, like the meta function there. It only takes attributes. And that's because the HTML element for meta is an empty element. It shouldn't have any content. So this library helps us to produce valid HTML in that sense. We can render this Lucid template in a handler instead using render text. And if we bring up our web browser, we see a nice message. And we can, yeah, if you look at in the inspector, you have the same thing as before. I think there's also, at least for Lucid, there's a converter from rendered HTML back to Lucid DSL syntax. So you can migrate more easily. Yeah, so far we have only sent HTML over the wire. We haven't done much useful things more than just greet people. And we might like to do side effects at some point to do something more useful. And we could do database queries, logging, call external services, what have you. And to do this with Scotty, we need to use a function called lift.io. And I'm not going to deep dive into what that means. It basically says, take this action, this IO action, and embed it in the handler, run it together with the handler. So as an example, we can look at this, this code where we have a type, article ID being text, basically an alias, and then we have some function, add new content, from article ID and some comment text to IO of unit. I'm not showing you any implementation, but it would probably be a database insert. We can then lift this IO action into the handler. So we accept post requests for this, this URL, articles, and then the ID and comments. We extract the article ID. We extract the comment from the form data. This is a bit weird that you're using the same function param to extract path parameters, query parameters, and form parameters. But anyway, that's how it works. And then we can run the, take this add new command, add new comment IO action and lift it into the handler. And finally, redirect back to the article. And one thing that we will fix later, I'm not going to say much more about it right now, but we're constructing a URL here with strings, basically. We're saying articles concatenated with the article ID. And we will see a more safe approach later. So Scotty is easy to get started with, especially if you're new in Haskell and Haskell web development. I can recommend this as a first kind of hello world thing, and you can build applications with Scotty, and yeah, but you need to figure out how to grow it, basically, and bring in libraries. So these are some things that you won't get in Scotty. There's templating, sessions, authentication, authorization, logging, persistence, and so on. You have to bring these in yourself. You can, if you want a slightly larger feature set, but still the kind of minimalistic approach, use a thing called Spock, which is similar, you can say. OK, over to Yesod. Now I'm going to tread very carefully, as Michael is here, but it's a one-stop shop, very carefully, for Haskell web development. And if there is a framework for web development in Haskell, I'd say it's Yesod, because it's very complete. It has really batteries included in that sense, while still being very modular. So you get a lot of things configured for you in the start, but you don't have to use them. So instead of having almost nothing and adding them yourself, you get a lot, and then you can remove the things that you don't want. So different take on that. But things fit together, and you don't have to figure out a lot of technical details to get them to work in the start. And Yesod also runs on Y using the warp server and so on. So it's compatible with all these things. Here are some of the features you get in Yesod. Type-safe routing is something that we touched upon building that URL with the string before. So Yesod has a nice way to do type-safe routes instead. And you can use the Shakespearean templates, as they're called, to do HTML, CSS, JavaScript, and even TypeScript. We'll see some examples of that. These tie together with a concept known as widgets, which are reusable components of HTML, CSS, and JavaScript. Yesod has an excellent form library for constructing definitions of forms that can be rendered as forms and that can be used to parse form data and get validation errors and so on. And also it has support for sessions and integration with a library called Persistent for working with databases, authentication, authorization, internationalization, long words, logging, configuration, and it has a auto-reloading web server that you can use when you're developing. So I recommend you start by using a template, and if you use Stack, you can run Stack templates, and there are a bunch of Yesod templates that you can choose from. So then you kind of generate your app, and you get a lot of things for free. There will be things in this generated code or this template that you maybe won't understand at first. But that's fine. I recommend you starting out looking at routing, templates, these Shakespearean templates, getting familiar with what's called the foundation type. I find this foundation type a bit hard to explain because it's like the global context for your app, where you kind of put all things that should be available in all handlers, something like that. But mostly just get something done and start hacking, because just staring at it for a long time won't help much. Just get to work. And then over time, you'll understand the things that are in the template and what you can swap out for other things and so on. And I recommend installing this development web server. You install Yesod bin, and then you run Yesod devel. In Yesod, you configure routes in a separate file called config/routes. Here we define two routes, one in the root for the home R resource, accepting GET requests. And the R after home is basically a convention saying this is a resource, or I'm not sure if it's route or resource, but maybe you can answer that. Yeah, no one knows by this time. Okay, and the second route is for article/some article ID. And here we see a nice thing. This article ID is basically the same as I shown before, but with a new type. So you have type-safe routes in here. You're saying it's not an integer or a string. It's this particular type, and this particular type has some parsing of a string to it. So you can do validation in here as well. We map that to the article R for GET requests. Okay, here's a handler, and this handler is found by naming convention. So if you go back, see home R get, that gets basically translated into get home R. So you have to define functions matching your routing file. And here we extract all articles, or like query all articles from some database perhaps. I'm not going to show you. And then we run the default layout, setting the title, and using the homepage widget. The HTML in that widget looks like this. And here we have access to the values that we had in scope in Haskell. So that's kind of neat. So we can loop over things and do if and so on. And we also see in the link in the last line how we use type-safe routes to link to other routes, and the compiler will check if you pass incorrectly typed arguments and so on. The next route had like a parsed article ID in the path, and so we get it as a function argument. And do a similar thing where we extract the article and the comments and render the article widget. And that looks about this, the HTML. So widgets are these reusable components of HTML, CSS, and JavaScript. If we say like widget file article, like this, Yesod will try to find these 4 files and include the ones that exist. So basically, you can add these as, if you want to style that particular page or that widget, then you can write this file. And these can refer to bindings in the Haskell code, so you can kind of interpolate strings or values into your CSS and JavaScript and HTML. And don't use this with very large CSS or JavaScript files, but then you can use external files instead and have type-safe routing to them instead. The CSS looks like this. This is in a Lucius file, but this would be valid CSS as well. But you could do interpolation here, which I'm not using. If we look at this in the web browser, we have the homepage listing a bunch of articles. And here is the article, one particular article, and we see some comments and so on. Very nice. This is like the default styling, basically, plus my little comment CSS. The next powerful feature in Yesod is forms. So you can write forms using applicative or monadic style. And you can use the same definition for rendering, parsing, and getting validation errors, which is very useful because they will stay in sync. And there are various renderers available. One is, or there are a couple of bootstrap renderers, so I'm using one of those for this example. Here's how you can define a form in Yesod. And this form is for comments. So it has a text field for the commenter name, and it has a text area for the comment content. And yeah, this is a single definition that's used both for rendering the form when you get the form page and for parsing the incoming form data when the form is posted. Here we use the form in a handler. First, we get the article and its comments as before, but then we call this generate form post. We get back a widget and some form encoding thing. We render the template, which has this part. I'm not showing you the full template, but this part is new, where we embed that form widget inside a form. And the action is also a type-safe URL back to the post version of this page. Yep, and in the post handler, we instead use run form post, which parses the form data coming in with the request, and also renders a new form if there are any validation errors and so on. So if we are successful in parsing this form and it doesn't have any validation errors, we have a comment, and then we can add it to the database and redirect as before. But if there are errors, we can re-render this post, but Yesod will include all the validation markup, like this field can't be blank, or yeah, this age should be over 0 or something. So you get that kind of for free, which is nice. In the browser, we now have this page. Looks nice by default, and yeah, very useful. So Yesod is very capable. You really hit the ground running in a way. Maybe you shouldn't start here if you're really new in Haskell web development, but it's a nice next step if you want to build something bigger. I can really recommend learning Yesod. Next thing I'm going to show very quickly because I might be running out of time. 5 minutes, okay. So Airship is a framework inspired by Web Machine and Erlang, which is very much about RESTful resources. So in Scotty and Yesod, you have some notion of RESTful resources and paths and methods and so on, but not the full-blown web machine thing going on. So what you do here is you use the default resource, which has all that behavior and sensible defaults of implementing a very nice kind of RESTful resource. And then you override specific methods to implement your particular resource. These are tied together using a routing DSL, looking something like this. So article / some variable article ID is routed to the article resource. Static / meaning the rest of the path, however nested it is, routed to the static resource. When we define our article resource, we take the default and override some of the fields. One of those fields is resource exists, which extracts the article ID from the path and just checks if the article exists. So this is a very minimal thing, basically answering, is this a HTTP 404 not found, or is there a resource existing? This override is a bit more involved. Here we bind first a special function for constructing an HTML response. And then in case the content type is text HTML, we get the article and render it. If it has another content type, then it's not in this list, we don't have a handler for it, then nothing happens. So Airship kind of does this content type resolving, and it's not strictly enforcing us, but it helps us not do unnecessary work if we would respond with like not acceptable anyway. So we can try this server using curl. Here we request something that doesn't exist. We get a 404. Simple. Here we try with the incorrect verb, put, and then we get a method not allowed. And if we pass a content type in the accept header that we don't support in the server, we get a non-acceptable. If we do everything right and ask for a resource without saying being picky about the content type, we get some HTML back. This is the happy path. There are a lot of things you can override. I'm not going to explain all of these, but yeah. Airship is a bit rough around the edges, kind of low level and bare bones. You end up in this build your own framework land again, but if you're doing RESTful APIs and you want that, it might be worth it. And for a quick little note on client-side technologies before wrapping up, if you still need to do a single-page app, I mean, you can use PureScript and Elm, and there are lots of others for Scala and F# and so on. But I really urge you to consider Haskell for your backend and doing server-side rendering as a kind of default, and then adding single-page apps for certain pages, maybe where it makes sense. As you're using Y, you can use a framework called Servant, which is really nice for APIs. So you can combine Servant with YesOrder, or you can write your API in YesOrder or Scotty from the start. But with Servant, you can generate types for Elm and PureScript, and you can generate API clients as well. So you get like a bunch of functions for requesting your stuff from the server. Summarizing all this, we'll get back up to ground level and fluffy stuff. I think it's worth evolving software without fear, or reducing that fear, using better tools for modeling the software and communicating our thoughts between us. Because programming is about communicating between you, yourself, your colleagues, and the computer. Really, there's this thing going on, continually evolving. So I think we should use tools that support that communication and that supports evolving your ideas over time, not only implementing the first version, which is usually not the correct one. Also, spend your complexity budget carefully. Like, large parts of your application are of lower value than a small part that represents your core business. Reach for simple tools as a default, especially where you have like a low value part of your application. Don't introduce unnecessary risk at that part. You have enough risk already, probably. So when needed, you can use more advanced tools where it makes sense and where you get some return on investment. And then there is so much good stuff in statically typed functional programming. And if you combine that with server-side web development, you get this nice toolbox. And with that, I'll thank you for listening. And here are a bunch of links to the slides. There are code examples in there as well. My website and my Twitter handle. So thank you very much. And I guess we have time for some questions. Some time for questions, yeah. Is there a microphone, by the way?
No microphone.
No, okay. Anyone? No? Yeah?